Okay, we're going to continue with this. So we have the situation where Augustus has decided he's gaining too much weight with his dad's plan. So now we need to see, he proposes, how about if you just give me 1 candy on the first day, 2 on the second, double it as we go. So we're doubling every day. So already I'm thinking that's going to be a geometric distribution. And if we double something every day, it's times 2 times 2. So a times 2 on our geometric distribution. But let's put it together. Model of the amount of candy he would get each day. You know, the first thing I'm thinking is I need a whole bunch of numbers. I'm gonna count my day numbers. I'm just gonna make a rough table here. It's pretty rough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll see if we need to go any further than that. And then candy. The number of pieces of candy. So this could be like n would be my day number, and then f of n would be the amount of candy. It's okay to make a table going sideways. It actually works out nice if you have a bunch of numbers, as long as you have room to put the answers in here. So on the first day we get 1 piece of candy. That's pretty easy. And then we, on the 2 on the second day, which I'm just doubling it, so that's times 2. And that's going to continue. So I'm just going to do times 2. 2 times 2 is 4. Then we got 8, 16, 32, 64, 128. That would be 256. And if we double that, 512. We double that, that'd be 1,024. We double that, we get 2048. Wow. In 12 days, he's already getting this many pieces of candy. That is a lot. So that's one way to model, is to make a table. We could do a graph. We could, do equations. We could talk about it in words, which we've already done. Actually, question 5 asks us to put together equations for this. So maybe we could go ahead and think about what these equations would look like. Knowing that it's geometric and the common ratio is 2, that gives us a good start. We want to use the model to predict the number of candies he would earn on the 30th day. So I would have to keep going and keep building my table here, 13, and go all the way up to 30. I'm not inclined to do that. So I think what I'm going to do is model this with formulas next. So let's look at number 5, and it wants us to write a recursive and explicit formula. So that's what I'm going to do. Recursive first. And remember, r equals 2, it's a times 2. So we'll start with the first term, f of 1 equals how many pieces of candy? 1. And then f of n, which is the now term, equals the prior term, f of n minus 1, times 2. That's another way to do a multiplication, times 2. Okay? Still, that's not the best way to predict day 30. Explicit is what we really need. In the explicit form, remember, it just starts with f of n equals, I'm going to go ahead and write this. It's f of 1 times the common ratio to the n minus 1 power. So let's fill in what that is. F of n is just our number of candies at any given time, and f of 1 is 1, and then times our ratio is 2 to the n minus 1 power. And we could actually write that without the 1, but I'm okay with it just like that. That's our explicit formula. Now let's use that to predict day 30. Oops. So I need to find f of 30. Alright, so using my explicit equation, f of 30 equals 1 times 2 to the power of 30 minus 1. You're just replacing n with 30 in the equation. And now we can solve this. This is 1 times 2 to the 29th power. Keep in mind that that represents how many times you would have to multiply by 2 to get to the 30th day. So 2 to the 29th power. I need my calculator. And I get 536870912. Throw some commas in there. 536 A million pieces of candy. More than that. Way too much. Okay. That's it for this video. Follow the instructions on Canvas to continue.